welcome to ECSAT, my new home since a bit more than 6 months. And I'm the Director for Connectivity and Secure Communication at ESA. ESA, as any of its member states, is going through times of change. And I'll try to depict a little bit where we are in that time. Roughly 6,000 people working for ESA across Europe. 150 here with plans to grow. I'll come back to that at the end. 6.5 billion pounds budget. I think there's a slight error on the £10 per head, but it's roughly 1 cinema ticket per inhabitant. In the US, it's 4. We are roughly implementing 60% of the European space budget. And we've launched 120 plus unique missions, and we have 40 plus upcoming. So there is excellence that was developed by ESA. Autonomous access to space. I think tonight we should see what was delayed from yesterday, and that would be another way, another vector of regaining autonomous access to space. The technical independence, although this is challenging because we see rapid evolution of technologies and we see a gap in chipsets in particular in Europe, where we need to collectively look at what could be a solution to avoid dependence. We are taking the pulse of the planet and of our climate. 25 terabytes of data are created every day. We're also looking at technology in a dual perspective between the civilian side and what we call security and frankly, for some projects, military. We also have a responsibility for STEM, inspiring millions of Europeans. I don't know if you had the chance to come to the campus during the open days this summer. It was quite impressive to see a multi-generational interest for what we do. And for us here, we're only 150. We had 3,000 people crossing the door. So that was really interesting. So more data, I won't bore you with that. But if we go to what we've done this year, Q1, Q2, we had astronauts coming back from space, astronauts going into space. We had, which is not on the slide, the Triton X mission on the 1st of March. Triton X is the new competitive and multi-mission European microsatellite platform line. Basically, it's designed to give access to space for smaller mission at a lower cost. We had the launch of Galileo. We had EarthCare, the inaugural flight of Ariane 6. And then when looking at the end of the year, we had additional launches. I'd like to highlight the Arctic Weather Satellite launch, which will be quite key to monitor what is happening around the pole. Some more Galileo launches. But we also had the Hera mission very recently, which I absolutely find fascinating. And hopefully tonight, the launch of Vega C with Sentinel-1C. Also Proba 3. And Proba 3, I'd like to highlight that we have technology and hardware that were done on campus by MDA that are going on board. So we're looking at connectivity and secure communication. We are at a time where, looking back, SATCOM has created a massive socio-economical benefit. £1 invested generated 13 down the stream. We've seen that the SATCOM represented 35% of the global space economy, 35% also of the upstream revenues, and it was responsible for 50% of the launches that we did with Ariane 5. The question is, for how much longer? And we're going through a massive crisis in the telecom area. We see newcomers coming in, mega constellations, and mega can be on different levels, but we see a massive number of satellites being deployed. In fact, an acceleration of this deployment. And the ability to scale is in fact reserved for only a few. We see large corporations coming in, new actors who were not necessarily close to space coming in, and we see potentially a very big market imbalance disrupting the traditional competition. So when you look at the market, roughly SATCOM was $162 billion, but the SATCOM is now part of a much bigger ecosystem. The global telecom, 2.8 trillion. And we see new actors coming in that were either from the big tech or from what we call the terrestrial operators. And altogether, we are seeing a paradigm where the traditional industry is suffering, yet there is massive investment coming into this sector. So how can we benefit from it? So you're probably familiar with the S-curve, and some of you have probably seen the slide before. But normally when you create a business, you go through different phases: build, expand, operate. And at one point in time, you have to reshape to keep relevance. You have different objectives per phases. You need different skills for each phase. And you normally start at the beginning. Today, our industry is in the reshaping phase. We are seeing consolidation in the UK. Inmarsat was bought by Viasat. We've seen intentions of SES buying Intelsat. We've seen OneWeb and Eutelsat merging. So there's a lot of movement, consolidation, basically, which is normal when you're in that phase of maturity. The problem is that SpaceX, and you could add soon Amazon, and you could add some Chinese players, are either in a build or expand phase. And my take is if we want to survive this current Darwinian phase of the business, we need to reinvent ourselves. And together with our member states, we need to act in the build phase. We need to relaunch a business which is viable. We need to work together and not individually on what would be the definition of the new telecom industry in Europe. So what we've done, and in preparation of the ministerial, which will take place next year in November, we defined 6 pillars to guide a little bit our member states and ourselves, and also to see if we have basically some echoes from the industry on what we're trying to propose. So the first one, and I'll start from the top right, is mobile convergence, 5G, 6G, and what is coming up is direct-to-device. We have in the UK operators, they have changed ownership, but they're still based here, that are very capable to work on this topic. Standardization is probably the way to go in Europe against proprietary systems which are being developed elsewhere. Quantum networking, optical communication. We started with demonstrations actually on Inmarsat, with later on EDRS, and we see that every satellite as part of a constellation will be equipped with optical links. This is a basic to start to think about quantum. And what we look at quantum, and I'll come back with some examples afterwards, is quantum key distributions. There are programs done nationally. There are programs also done with ESA at a European scale. And this will be, again, the beginning of what we call QINs, quantum information networks. On campus, here, there is a quantum national lab. I think that there is a lot that can be done with the capabilities on campus and with the other member states who are investing in quantum. Interplanetary connectivity, you're probably familiar with Moonlight. Moonlight is a project that will deliver telecommunication and navigation on the moon in preparation of what we call a lunar economy. And we strongly believe that it could also help develop additional exploration missions where we don't need to send big, large satellites with a big telecommunication package, but rather a smaller one that could communicate to a relay that will bring the data back on Earth. This is an enabler for surface activities and most probably underground activities where potentially big value, big dollars or pounds are. Governmental connectivity, we are working on the continent with the Commission, but we're also looking at what we call light gov missions. And I'll give you two examples. One around air traffic management. How many hours have you spent last year flying around just waiting for your slot to be free to land? A massive inefficiency, but massive ecological problem as well. We need to work on the efficiency of our air traffic management in Europe. And this is potentially one of the missions that could also build an additional bridge between the UK and the rest of the continent in that matter. Maritime surveillance, adoption of new standards of communication, being able to monitor illegal fishery, being able to work on potential immigration flux, which are not under control. And we can invent further missions with a governmental interest, meaning it could be commercially operated, but with a governmental anchor customer behind. Spectrum sustainability. For those of you who are telecom experts, it might be obvious, but spectrum is a finite resource. And with the multiplication of assets in space, we're going to see potentially more and more interferences. How do we protect our European operators, our UK-based operators, to be able to deliver a service of quality to their customers and therefore being able to generate revenues, profit, to keep on investing into new technologies, new assets, and basically exist. This is a massive issue also for navigation purposes. We see it at the border with Russia. Some aircraft have actually to land because the navigation signal was jammed. And then industrial competitiveness, how can we support you to mature your technology? How can we support you to think in products and to actually export? To not only work on a technology, but to insert this technology into a product, a system, a subsystem that will then be resold elsewhere. Some examples, and I will not go too deep into them on what we're doing. Sunrise, working with many UK companies. We have Pioneer. You can see a lot of British flags on the slide. We have quantum. I mentioned it earlier. I think this is an area which is a real gem, and we have the capabilities on campus to work further. We will work with Honeywell after the innovation of the contract for QKD from ARKit. We have air traffic management, the IRIS project done with ex-Inmarsat, Viasat, adopted by EasyJet, adopted by ETA, and we are supporting the adoption with many other airlines. This could be a very, very interesting and promising avenue. Direct to device. This is the nut to crack to reach the millions. that so far SATCOM has not been able to. Again, Viasat, Inmarsat are the only one in Europe having a spectrum which is harmonized for this potential. So there is a real gem here. We need to work on it. The moon, I mentioned it. The COM payload, the COM elements will be operated from the UK. Another potential flagship to be highlighted. And I will just jump directly to the conclusion. ECSAT, you're here. This is a mini representation of ESA. 150 people might not be a lot of people, but in fact, you have access to almost all the directorates at ESA through us here. And when looking at an investment at ESA, that means you are basically looking at other member states working on this mission, working on this project, and multiplying your investment. So working with ESA allows the UK, for the missions it deems interesting, to multiply the initial investment. So we are working on, and I'll jump because time is running, on the plan for the next 10 years. And I will stop with this, this slide. Our vision is, one, to reinforce the existing capabilities. We can do better, we can do more with what we have. We need to look at the campus and the wider UK ecosystem. We want to work on ideas that could be generated. You mentioned in-orbit services, nuclear power, and we are looking at sustainability, green element with the constellations and number of satellites. What we want is to propose ideas to UKSA and to see if there's are of any interest to be adopted, either nationally or with ESA. And then we'll look at expanding through new actions. And we've created, together with Dave Parker is in the room, what we call an idea factory. This is basically a community of willing minds to spend some of your brain juice on what else can we do together. There's no money, but there's a lot of rewards in seeing an idea being adopted. The money will come later. Thank you.
Great, some fabulous messages there. Thanks, Laurent. Got time for one or two quick questions?
Hello, I'm Adam from NAMO. Are we to regard ECSAT as our local route into ESA? Because currently we're not really, my company's not using you that way. We tend to go to technical officers in ESA. But is your ambition to be really our hub that we can come to and work with you?
So my intention is not to replicate what exists with 2,000 staff members in the Netherlands, for example, but indeed to be a conduit and to have local interfaces for key topics of interest in the UK. And my target is also to be an interface to UKSA for other agencies in the UK and potentially to further develop what we talk about in terms of dual use, because a lot of the technologies we're working on is inherently dual use.
More over there.
Hi, Liz Quintana from Ofcom, the telecoms regulator. So thank you very much for your shout out on Spectrum and also for direct-to-device. This is something we're also really interested in. It's something that's being discussed internationally. We just announced that we'll be consulting on an authorization for this in the UK next year. So thank you to everybody who contributed to our call for input this year. It looks like D2D will need the support or partnership of many MNOs. And in Europe, there are several MNOs that have a global footprint. And so while I appreciate ESA might be in the build phase, in your S-curve, it seems like there could be others across Europe that would put you in a more kind of mature position than maybe we think we are. So would like your thoughts on that, and also on maybe the kind of supporting components that maybe European SATCOM and actually mobile ecosystem could provide into that. So it's not just about the satellites per se, but the whole system that would be required to deliver something like that. Thank you.
Thank you. I think this is a very important comment. It is not space for direct-to-device. It's the unification of the terrestrial and the non-terrestrial world. And indeed, the terrestrial actors have a lot to bring. There's one little caveat that we need to work on. It would be so much easier just to bring a G-Node B ground station in space. But in space, the problem is we face power limitation because we cannot launch something too big in large quantities, and we face radiation issues. So we need to work together, and this is where also the work takes place in the 3GPP groups, which are working on the standards for the adoption of the space community for the terrestrial standards. So very valid point. On the ability to work with terrestrial operators, you see some of them, Deutsche Telekom working with SpaceX, allocating some of their own spectrum to be able to deliver a service. I think you said, Alice, in the previous presentation, in Europe, the geography is much smaller, and therefore we have more complications when you need to switch from one country to another. Whereas in the US, you have a much larger territory, and it's a little bit easier to deliver a service, in particular in the white zones. And that's where we need to work with the regulators and where we need to also influence a little bit what will be discussed at the next ITU conference.